All right. Well, thanks, Kyler and Gordon, for setting this up. I'm Dylan. For those of you who don't know me, I'm a UI engineer on the Practice Fusion product. And today I'm going to be talking about enhancing cascading merges within Practice Fusion, where we automate failure alerts and release branch reminders. Tongue twister. All right, so an overview, I'm going to talk about what is a cascading merge, the problem with cascading merges failures, the solution to that, which is automating the alerts of them, and then the other problem with merges too closely to the ship date, and then the two solutions that I came up with that. So first, to give a background, Practice Fusion UI uses a mono repo. It's called Carbon UI. So we use a cascading merge strategy to streamline the deployment process. So everything in the release branch ships out to prod on the specified date. It's made it really easy for us, and we don't have to cherry pick things because a mono repo can make that a little challenging. And then for all of the presentation slides before or after this, we use a 2-week release cadence. So that's where you'll see the two different releases. But more formally, that cascading merge looks like your PR targets the release branch, which then cascades to the next release, which then hits main. So the problem with cascading merges is you don't know when your PR is merging if it's going to have a merge conflict between the two release branches. So subsequent PRs merged into a release branch will continue to fail down, and those merges won't be cascaded down to the subsequent branches, and all of that needs a manual resolution. So that kind of looks like, your colleague put in a feature to the furthest release branch 917, and you're merging something in after your colleague to 903, and there's a merge conflict between those two files that needs some manual resolution. So the solution for this is actually quite simple. There's a Slack and GitHub action that allows us to communicate between Slack and GitHub. So all we have to do is create a webhook in Slack, which I won't get into. It's pretty simple. You can look it up, but you create a webhook in Slack that takes in some payload, and then it can spit out that message to a Slack channel. And then the last thing I did was augment the existing cascading merge workflow. So I needed to get those output variables. So these, target branch, source branch, and the conflicted files. And then this is the GitHub action to send that out to Slack. And so the output kind of looks like this. And we have this going to our kind of all UI group chat so that the tech leads can address these merge conflicts when they happen to hopefully kind of solve the issue sooner. All right, so the other problem we have run into with cascading merges are merges too close to the ship date. So last minute code merges into releases creates a time crunch for quality engineers, leading to rush testing of potential quality issues. And in the busy workday, reminders to developers to change their target branch are often overlooked. If you're ever looking at a pull request in GitHub, like if you look at the very top where the target branch is, it's really common for us to overlook that, and because you're trying to get to the meat of the changes that are going in. So there's two ways we can automate that, reminders for that in GitHub, but we have to create it into two different sub-problems, and that's pull requests that are opened before it's a week out from shipping, and then pull requests that are new that are open when their target release branch is less than 7 days out. So the first solution is the biweekly reminders. So we have a 2-week cadence, as I mentioned. So we can create a biweekly GitHub action to kind of grab all the PRs that are targeting the next release branch and then put a comment on the pull request to say like, hey, this is going to be shipped out soon, doesn't need to go out. And that's kind of what this image here is on the right. And code-wise, a little bit involved. So the biweekly reminder, we just kind of create, again, an every week, every Tuesday GitHub action. And then we do this cool thing where we have an environment with the first start date, and we do kind of a difference of what is today's Tuesday versus the start date, and it's an alternating flag. So if it's on the biweekly or on the off biweek. And then that is used to determine if the following action should run. So this kind of grabs all the pull requests and then comments. So this uses the GitHub script action, which adds a ton of cool features. But most importantly, all we're using is OctoKit. And I'll get into that over here in a second. But essentially, we just grab the next release, which is pretty trivial. That just queries the repo for all the protected branches. And then we filter using some regex to grab only the release branches and then do some date comparison by parsing out the date to find the earliest release branch. And then once we have that, we're able to get all the pull requests targeting that branch. So we can just pass in that release we just found, and that'll give us all the pull requests. And then lastly, we just need a comment on those pull requests. So we can take all those pull requests we just got, and we have a body here. I created some constants so we don't have to constantly re-reference those. Yeah, so that's what comments on the pull requests on a biweekly schedule. And then the other one is, cool, yeah. So reminders on new pull requests. So pull requests that are opened after that biweekly hit, we need another mechanism to remind developers. So essentially, we're going to create a new GitHub action when the pull request is opened and check if the target branch is less than 7 days away, using that same GitHub script action that uses OctoKit. But different than the biweekly requests or biweekly workflow, this one needs to fail silently. So if GitHub commenting on the PR fails, we don't want the pull request to be stopped from being merged. This isn't important. It's not like an automated test that should stop a pull request from merging. This is kind of some additional information. So that looks similar to the last one. So this one just runs when the pull request is opened, synchronized, and reopened. So that's adding new commits, reopening it from being closed, and then creating a new pull request only on release branches. And then using the same kind of helpers I had for the biweekly reminder, but the new addition is this is released shipping soon, which just takes the target branch of the PR and then parses out the date and then does some, conversion and then checks if it's more than 8 days away. And if it's not, or if it is less than 7 days away, then we'll use that same comment on the pull request helper we had created earlier. It takes then this constant to comment on the body. And then, so the failing silently uses that same GitHub expression that I used for the cascading merge failure, and then it just comments that it fails so that it doesn't hold up PRs. And cool. So lastly, a part of this process, I learned about GitHub action summaries. I'm not sure if anyone has experience with those. And there's two ways you can comment to these summaries. The simple way would be using echo and then outputting to the GitHub step summary using bash. And the more complicated way was the GitHub action scripts, which adds OctoKit, had a more complex way for adding better markup summaries, which then looks like this. So the top half is the bash version where it's just kind of a, strings being output. And then the bottom half is that table I was able to create using OctoKit. And so now when I look at these actions and when they run, I don't have to go through the steps of the action to find out like what PRs it's commenting on or what step failed, if any step did fail. I can just go to the summary tab of the action and get all the information I need. Future improvements. So when I first created the Slack communication, I use a Slack webhook, which is called a Slack workflow, I believe. But we have TechBot 2.0. I don't know why that slipped my mind, but that would enable us to have better text markup. You can have like cool buttons and fun styling. So that's something I would look into. And then the other thing is the pull request reminder that is on PR open. Technically, will re-comment if a pull request adds a new commit. And that can be a little annoying for people because they don't need a ton of comments to remind them that like this is about to ship out soon. They only need one. So that might be something I might look into more in the immediate future. Probably just check if we've already commented before and then, suppress subsequent comments. And yeah, that was it. Does anyone have any questions?
I saw that you were centralizing problem PRs. Where is it posting that summary at? No, it's running. It's in the actions repo when it runs.
The summary.
Yeah, so where it's showing all the problem PRs.
Yeah, so actions, you go to biweekly, and I think this one might have had some. Yeah, so you go actions, find whatever it is, and then run to any instance where it's ran. And then this is the summary tab, as GitHub calls it. So yeah, normally I'd have to like go into the step, open it up, figure out like what did it do. But now I can just click the summary tab and it has all the fun, cool things I need.
That is really cool. I thought it would be within every pull request and you'd have to open all of them to see their statuses, but centralizing it like this is that's very cool.
Yeah. Cool. All right. Any other comments or questions? Cool. Then I'll hand it back to you, Kyler.
I love to implement features from enterprise toolkits, and nothing makes me happier than doing that. So I think Kevin was initially pitched this idea that like we need to brainstorm about how we should do this, and I was like, I think I know how. I know it. I haven't visited this idea in a couple of years, but I think I know how. So we've implemented this now in the Chia repo, which has a new name. I haven't cottoned onto the new name. I just call it Chia, like the little plant that grows. And we get notifications in Slack when we run our overnight drift check to say, go look at this repo. It looks like there is a drift, which is really easy to remediate. So let's talk about how it works. We have, I think, 15 repositories now that are all deployed many times. So here's all of them. Eventually, we'll have, I think, 100 of these data files, something like that, for all the pod layer, at least pod database, pod network, pod servers, and I think maybe pod storage, just because we'll have so many pods, we scale out horizontally for this product. And sort of checking to see whether there's drift is a huge pain. In the same way that Dylan sort of centralized all of his code in one place, we need a way to do that somehow. This doesn't do it great. I'm going to copy some of what Dylan pitched for this. But let's talk about how this works now. So when you do a pull request, this is Terraform, and we check all the environments by doing a Terraform validate and a Terraform plan. And up here you can see like all these locations for the Terraform validate, and it's run when you have a pull request that targets main, that targets the deploy branch. These are very simple. There's not a lot of merge coolness like the stuff that Dylan solved. It's simpler, thank goodness. And we run a matrix, which means we concurrently check all of these things. We build a bunch of stuff in Bash that we just basically use to pass to the Terraform validate, which is a centralized action. And we pass the key and the location and the client and the, whatever else that an action would require to build a Terraform workspace and synchronize to the backend and authenticate and use an SSH key to clone all the modules and blah, blah, blah. So it just does that. That's all we've really cared about. It's a Boolean 1 or a Boolean 0. Okay, like it was able to build the Terraform plan. Even if the Terraform plan is going to destroy everything, mind you, as long as it works, it gives you a thumbs up. That's how it works today, or at least how it worked before we made these changes. So we already have an action, this one, that runs every workspace. it runs all of them concurrently. So what we decided to do was add a schedule. So you can do that with cron in actions. And so it just runs nightly at this point at 11 p.m. Central, midnight Eastern, and checks all the things, like it checks every layer. But we also added some additional logic. So let's switch over to it. So it does all the normal stuff, like it validates the storage container exists, and it logs into Azure, because this is primarily an Azure-focused product. That's all stuff that you're probably familiar with. And then we Terraform initialize and validate, and just all the standard, make sure this Terraform stuff is linted and works and whatever. We do a Terraform plan, and we added an output. So when you run a Terraform plan, it can output a binary file that represents what it's gonna do. That's a really great step when you're doing a deploy. So like the plan that you approve matches exactly what it's gonna do. You should all be doing that. And if you're not, come talk to me. We should fix that. But here, we're not going to apply this one, but we are going to read it. So we run the plan, we output it as a binary file, and then here's the drift detection thing. We set it to only run during schedule because I don't want to alert our Slack room when a PR branch has drift, because it'll always show drift. We're changing the code. Of course, it's going to do something. So we only do this step when it's triggered by a schedule, by cron. We read the plan, Terraform show, the Boolean plan. You can't just cat the file because it's binary and it comes out as gibberish, but Terraform show reads it, decodes it from the binary to just a flat text file. And then we just look for like, your infrastructure matches the config, your Terraform will perform the following actions. Just, is it actually working? And then we check to see if there was an error. Is there something wrong with it? And then we look to see if there's any changes. If the exact string infrastructure matches the configuration, you'll see that in every Terraform plan where it says like, there's no changes. This is perfect. This code matches this environment. There are no changes. We basically just exit. Like there's nothing else to do. If it exactly matches, there is no drift. That's a success. Sweet. If it says will perform the following actions, that string is always present if there's anything that's drifted at all. Even if it's a single tag or something, like it's tiny, minute, don't care, we still do care a little because it's still drifted. So we say there's drift, and then we set some variables. We look up the repository, we look up the action run, so like the literal link to this actions run, so you can see, like you can click through to it. And then we don't use that cool add-on that Dylan does. We just did a curl, but it's to the same place. It's still to a webhook for Slack that you can just build here. Like this is the Terraform drift detection. It lets you set cool little pictures and say who it is. Like this is literally posting as user TF drift detection with a little Terraform logo. And it basically just posts using curl these links. And when we actually run it, it looks like this. Terraform has been detected here, and it just posts overnight. It runs about 75 workspaces, so it checks all 75 concurrently. We pitch a lot of jobs at the Neon builders. Thankfully, they can handle it and queue them up. And basically, it says in this repo, which is a link to the repo, in this environment, which is a link to the run, I found some drift. You should probably go fix it. And then we basically just kind of triage it each morning. Like, did someone merge a PR and not deploy it? Did someone make a change to the environment and we need to revert? And we just manually, at this point, spin off tickets and reversions and action runs and whatever we need. But it's a really great, like, heartbeat on whether our environment has any drift. And in that way, we used bash scripting in about 2.5 hours to build an enterprise feature that Hashi will make you pay for. And that's pretty cool. I think that's the end. Does anyone have any questions? We have big plans for this. I can talk about that if there's no questions.
You could click through one of the examples there.
Yeah, for sure. Okay, so this is pod database, and I'm going to click through the stage environment. And it takes you right to the run. It doesn't take you right to stage, so you have to remember. In my goldfish memory, I have to look it up. And we have summaries. We're doing kind of a Dylan-esque thing. I think Alex initially built this. For each one, we print out a little, like, here's the dev layer of this environment, and it's doing stuff. So here's 1 created, 0 destroyed, 0 replaced. So you get this really cool look through, and it says, oh, there's one created. It's the file share. You can still click through the actions and see the Terraform output, but that's a lot of scrolling, particularly with 50 or 100 layers. So we're just building tools as we go to prepare for that eventuality of having like so many gosh darn layers that we can't keep up. So we look through here, stage, Terraform validate. I'm going to jump all the way to the bottom. We do see drift has been detected, but right here it says, something's being created. And that's why drift was detected, and then that's why drift was posted. Posting notification, cool. We have big plans for this. I want to talk about that because I think that's interesting. So right now this is run in the Terraform validate layer, Terraform validate phase, which is not capable of doing anything to fix it. It just tells the humans that something's happened. And that's useful, but it's not the most useful. Something that I built a long time ago is a risk ranker for Terraform plans. And it reads your Terraform plan and it tries to decide if there's anything that's risky. And that's hard to do without, like AI or something interesting. But basically, I just said if it was a create or a modify, it's okay. And if it's a delete or a recreate, it's not okay and it requires human approval. So for 100 runs a day or something in Azure DevOps, it would rank the risk of plans and then decide whether a human needed to approve it or whether it could just be automatically approved. So what we are thinking for the next few months, maybe, is move this check over to TF batch, which runs all of the layers and can possibly do deploys. It's something we built to just do all the things. And so if we do a drift detection of this, like if cron runs this overnight and it sees a drift, we could have it check whether it's too scary to automatically approve. And we can say, hey, there's drift, humans, you need to fix it. Same pattern as before. But if we classify it as a safe change that we are comfortable with our automation to automatically deploy, then we could do that with no human approval, like no additional human pause step. And we think we're going to do that. We're still trying to figure out, is that too risky for us? Is that something that only lower environments would do versus upper? All of that's configurable because it's code we're writing, so we can do what we want. But that's the future. That's what we're thinking for doing this. And as we formalize these standards, I would love to dog food it with other teams. So if you're interested in this cool hierarchical stuff and automated deploys and drift detection, come talk to me because I want everyone to do this. It's been really good for us. It's been very helpful. So bring it on. Okay, we have 3 minutes for questions. I talked a lot. Any questions from anyone?
Not a question, but a comment. Having that summary table for what's going on has been a lifesaver for PR reviews. Right? It's amazing because trying to dig through, 10 different, plans over there and look at the details and have to scroll to the bottom and if you can skip all of that because I see 000 across, I only have to focus on the one particular, and even there with that dev east us2, you can expand and see, what is it it's trying to do? It's been super helpful on PRs.
Absolutely. The Practice Fusion one is just one table. We haven't implemented it quite as smoothly, so it's a whole bunch of tables, but you can still scroll and see which ones have stuff. Dev East 2 has nothing. You just get a little blue dot. But for all the other ones, you get eyes because it says, hey, you should look at this. It's doing something.
This may be a crazy question. With all the drift detection, let's go with technology. Is this something that we could potentially plug into custom models in Copilot?
Yeah, I think so. When I pitched this on LinkedIn, I've talked to other engineers that have done that exact thing. They're doing the riskiness of changes and getting a score back from a Copilot type tool and then automatically approving stuff or writing a summary of what's going to happen to inform whoever makes those changes.
Okay, cool. I saw that they had the public beta out for custom models.
That would be pretty slick, honestly.
That'd be so cool. Mm-hmm.
Yeah, Terraform in general already does a pretty good job of laying out what's going to be happening in the environment. But having the summary and auto approval in place, that's a whole new level of fun.
I think our strategy forever has been like work really hard so we have to do nothing. Like I want to kick my feet up and be lazy forever. So how can I do that? And this will let us kick our feet up, hopefully. Okay, we are at time, so let's close this up. Thank you, Dylan, for coming. Thank you, me, for speaking, but also anyone else, if you would like to speak here, we would love to have you. It doesn't have to be like incredible stuff. Clearly, like for me, it's just a little widget I built that does something cool. So please reach out to Gordon or me. Thank you, everyone, for coming. Happy Thursday.
Thanks, everyone.